Alright, ladies and gentlemen, here's the practice exam video for the matter and energy test. Ignore the matters. That's really silly. Wasn't me, but guys. Alright, number 1. Which change is most likely to occur when a molecule of H2 and a molecule of I2 collide with proper orientation and sufficient energy? So you don't need to worry about all that. You're just thinking about these two things colliding with each other, so two elements coming together. That's a reaction, chemical reaction. So when two elements come together to make a compound, what should we think? Oh, that's a chemical reaction, so that is a chemical change, okay? Because a compound's being formed here. All right, now number 2. Which type of matter is represented by the particle diagram? So if we look at these guys, it's composed of one of these white dots and another one of these black dots put together. So when two elements are bonded together, we have what is called a compound, not an element. And mixtures here have to be composed of different types of substances here. Compounds is when you take two different elements, at least two different elements, and combine them together. Okay? Now number 3. Powdered iron is magnetic, but powdered sulfur is not. What occurs when they form a mixture in a beaker at room temperature? Alright, so anything about mixtures here. So key thing about mixtures is that components retain properties. So here this mixture is containing both iron and sulfur. So each of them are going to keep their own properties. They're not going to gain one from the other. All right. So sulfur is not going to gain properties. Iron will definitely retain its magnetic properties. Iron will not lose anything. Neither will sulfur gain magnetic properties. Okay. So in mixtures, components here retain their properties of themselves. Whereas in compounds, when you combine elements together, they're going to lose themselves and become this whole new substance, a compound. And they're not going to be the same as they once were. Whereas in mixtures, you could separate them and put them back together, and each component will still retain its own individual identity. All right. Now, number 4. Which sample of CO2 has definite shape and definite volume? We should always think solid. So that's their choice C. Let's pick a different color now. Let's go with blue. Number 5. Given 4 particle models, which 2 models can be classified as elements? Alright, so that means when we say elements, that means we should see one of the same type of element. Same type of dot, no mix of different dots. So if we look at model 1 here, that's not a possible choice because look there, it's composed of different types of atoms, as is particle model 4. If you look at 2 and 3, they all have the same types joined together. So those are all elements. So this is choice B here. Number 6 now asks which statement describes a chemical property of silicon. So when we think chemical property, we're going to think reaction, anything related to reactions. Okay. So now we're looking at choices that deal with anything related to reactions, and that's choice C. If you look at choice A, melting, you might think melting might be kind of a chemical, but it's not. Phase changes are physical properties. Physical changes, sorry. Brittleness and color, that's all physical properties. Chemical properties, again, is how it's reacting with others. Alright, number 7. Which substance can be broken down by chemical means? So we're looking for a compound, not a mixture. Mixtures is by physical means. So that means we're looking for 2 different elements, and that's choice C. Number 8. In which sample of water do the molecules have the highest average kinetic energy? Alright, average kinetic energy is related to temperature. When you get to me in physics, kinetic energy happens to equal 1/2 mv squared. Just a fun fact for y'all. That's what I'm teaching right now in physics. How coincidental. Anyway, average kinetic energy is temperature, so we're looking for the substance with the highest temperature, and that's choice C. 20 mLs at 100 degrees Celsius. So it doesn't matter how much volume of water we have, we're looking only at these temperatures. Degrees Celsius is a unit for temperature, so we need to look for the highest one. Number 9, a 100-gram sample of H2O at 22 degrees Celsius absorbs this much heat. What will be the final temperature of water? So we're looking here at temperature changes, all right? So that means we're using this MCAT equation, Q equals MC delta T. Notice here, 8,360 joules. That is heat energy, that's Q. Practicing for physics next year. 100-gram sample, that's your mass. That means you should put units. Now C, we have a sample of water. That means we need to look at table B for that C constant. What is the value of C? That's 4.18 joules per gram. Degrees Celsius or Kelvin, doesn't matter. All right, and we're looking for delta T first. And so when you do the math, plug and chug into your calculators. 8,360 divided by 100 times 4.18. All right, so you should get that delta T is equal to 20 degrees Celsius. So we are absorbing heat. We should be going to a higher temperature because we're gaining heat. We're going to get hotter, higher temperatures. So we're going to increase by 20. If we start at 22 and go up by 20, our new temperature will be 42 degrees Celsius. Not choice B, that's your delta T. That is not the final temperature. Our final temperature is the new one we're going to. All right, number 10. Which temperature is equal to 120 Kelvin? So you got to look at reference table T for that equation, where Kelvin is equal to degrees Celsius plus 273. We're looking for its equivalent in Celsius. So we plug it in, 120 equals degrees Celsius plus 273. You have to subtract 273. 120 minus 273 will get you negative 153 degrees Celsius. That's your answer. And lastly, number 11, which formula represents a mixture? Okay. So, fun thing about mixtures, an easy way to look out for solutions. Solutions are also denoted as aqueous symbol right there. AQ meaning aqueous, you mix it with water, and that's choice D. Voila. All right, number 12. Given the balanced particle diagram equation, which statement describes the type of change and chemical properties of the product and reactants? So product meaning this side and reactants meaning this side. We'll elaborate more on that later in a later unit. But anyway, here we have, look here, one element and another element. Two elements combining together to yield a compound. So we are producing a compound here. This is a chemical reaction. We're dealing with pure substances. So this here should definitely spark your brain to think chemical changes. So cross off A and D. Okay? And with chemical changes, products and reactants, compounds and elements all have different properties. They're not going to have the same identities. It's different properties, different identities. Choice B. All right, number 13. Sample of water is boiling as heat is added at a constant rate. Which statement describes the potential energy and the average kinetic energy of the water molecules in this sample? So key word, water is boiling. Boiling meaning phase change. Okay, when we're undergoing phase changes, that means if you think to our heating and cooling curves, kinetic energy is constant. Temperature is constant. Okay, because the temperature remains the same there. So we can cross off C and D because kinetic energy stays the same. Now we're thinking about potential energy. So potential energy, going from water as it boils, that means it's going from liquid to gas. So because we're going from stable to less stable, we're going to a less stable state of matter. That means potential energy is going to increase. So the less stable it is, the more unstable. Gases are so random, they're so unstable, they're going to have a lot of potential energy. Okay? Potential energy increases and average kinetic energy remains the same. Okay? If you go the opposite direction, going towards solids, potential energy decreases because solids are so stable. All right, number 14. What is the total amount of heat? That means we're looking for Q. To vaporize 1 gram of H2O at 100 degrees Celsius and 1 atmosphere. All right, so keyword here is vaporize. We're changing phases here. H sub V, that's what equation we're looking at. So let me do this here. Q equals mHV because we're vaporizing, we're changing phases, and our substance here is water, so HV is going to be looked at on table B. So we're looking for Q. We have 1 gram of the substance, and if we look at table B, HV is equal to 2,260 joules per gram. Okay? 1 times 2,260. This should be easily done without a calculator. 2,260 joules is our answer. Joules is a unit for energy, all types of energies. Remember that for physics, guys. All right, number 15, the temperature of a sample of water changes from 10 to 20. So we're having a temperature change. That means we should instantly think MCAT equation. When the sample absorbs 418 joules of heat, what is the mass? So Q they gave us is 418 joules. C, because we're dealing with water, you have to look it up. 4.18 joules per grams degrees Celsius. Delta T, going from 10 to 20, that change is 10 degrees Celsius, and we're looking for mass. So plug it in. Joules equals M times 4.18 times 10. So 418 divided by 4.18 and 10. 418 divided by 418 times 10. That should give you another 10. 10 grams. Plug and chug, guys. Number 16. Let's do this in purple. Okay. During which intervals in this cooling curve is potential energy decreasing and average kinetic energy remaining constant? So it might be easier to remember that kinetic energy is equal to temperature. So you're looking for where temperature is constant, and that's during these guys, B, C, and D, E. And oh look, it's choice C. And potential energy changes during these phase changes. So remember that these guys here are where phase changes occur. Okay. Number 17. What is the total amount of heat? So we're looking for Q again, required to completely melt ice and water. So HF. So melting, think of fusion reactions. Not fusion reactions. That's completely different. So think of fusion, phase changes, melting. So since we're dealing with ice and it's going to be water, H2O, we look it up on table B, and HF is 334 joules per gram. And at its melting point, so that's not important for the equation, our mass of the substance is 347 grams. That's a lot. So we're looking for the amount of heat energy here. We're multiplying these two numbers together, 347 times 334. Plug and chug, 347 times 334 is, whoa, that's a huge number, 115,898 joules. And that's approximately choice C. So it's okay if you get a number that doesn't look exactly like the answer choices. You pick the one that's closest, and this clearly rounds up to that number. Just saying. Get used to having uneven numbers and a long string of decimals, guys. All right, next, number 18. During interval AB, which energy change occurs for the particles in the sample? So let's think. What phase changes are we going through? Oh, we're only talking about energy change. My bad. Okay, energy change. So we are here and during a phase change. So that means PE, potential energy is changing. okay? And because we're going from a solid to a liquid, solid to liquid means we are increasing in potential energy because we are becoming less stable. So potential energy of the particles increases. That's our answer. Because average kinetic energy, temperature stays the same, and it's all about potential energy right now. Number 19. Which statement describes the transfer of heat energy when ice cube is added to an insulated container with 100 milliliters of water at 25 degrees Celsius? So ice cube, meaning it's water as solid. So clearly, that's going to be 0 degrees Celsius, because remember, ice has to be at least 0 degrees or below, because that's when it melts. It melts at 0 degrees Celsius. So ice is cold, water is warm, or hot in comparison. Heat always travels from high to low. So here, the heat is going to travel from water to ice. So the ice cube gains heat energy and the water loses heat energy. That's our answer. Number 20. 2 grams of potassium chloride are completely dissolved in a sample of water. This solution is classified as a homogeneous mixture. That's always the case, because when it's something completely dissolves, it evenly mixes itself around. Okay, let's pick a different color and let's go with blue. Number 21. Any substance composed of 2 or more elements chemically combined in fixed proportion. These are all key words for a compound. All right. Now looky here, we have a percent error equation problem. All right, so you're thinking, it's like, we never talked about percent error in class. Well, we did something like this in lab. We did a lab with having to deal with percent errors. So in case you didn't know, you could find this equation in the reference table, table T. Okay, so don't fret. Table T. So percent error is equal to measured value minus accepted value over the accepted value times 100. Okay, so we're looking for numerical setup, first of all. So our measured value is what the person found, 80.4, and the accepted value is the actual, 80.6. So you gotta make sure that you have 80.6 in the denominator. So looking at B, C, and D, that's not right because they don't have the accepted value in the denominator. That's only choice A. Now number 23 is asking you for you to actually calculate it. So following this equation, just plug the numbers in. Let's use a different color, green. So here, for number 23, the accepted value is the actual, is 80, and then our measured is what the student found, which is 88. So that means percent error is going to equal 88 minus 80 over 80 times 100. So it's going to equal 8 over 80 times 100. That's 1 over 10 times 100. That's 10%. Okay. Number 24, state the physical property that makes it possible to separate a solution by distillation. So distillation is basically the same as boiling. You're boiling substances, and it takes advantage of their different boiling points. So for number 22, it's boiling points. 24. Because if you imagine 2 substances, salt and water, imagine if they had the same boiling points and you reach that same temperature. Both of them are going to disappear together. But if they had different boiling points, one of them is going to disappear first and you're left with the other one. That's why it works. All right, number 25. During which time interval is the average kinetic energy, which is temperature, of the particles constant? So we're looking for these guys, while potential energy increases, either BC or DE, and it's choice D. Number 26. In which equation does the term heat represent heat of fusion? So fusion meaning we're going between solid and liquid phases. So looking at choice A, liquid and gas, that's vaporization. C and D deal with multiple different substances. We're not dealing with chemical reactions. We're just taking the same substance and changing its form here, physical change, phase changes. And so looking at choice B, solid to liquid, that's what we need. All right, number 27, identify the physical change occurring during the time interval 4 minutes to 9 minutes. That's a phase change. And what specific phase change? Because you got to play it safe and know what phase change it is, especially. So if you read the prompt, it starts out as a liquid, and then it cools. So here we start with the liquid, and when it cools down, it changes phases, it cools down to a solid. So what a specific phase change is this? This is freezing. Freezing a liquid into a solid. Okay, that's number 27. 28, state what happens to the average kinetic energy in the sample during the first 3 minutes. So right here, it's decreasing because we're decreasing temperature. Number 29, describe one property of sand that would enable the student to separate the sand from the other components in mixture B. So what method are we using, first of all? Okay, we got a salt here. We got sand and we got water. So sand can be used to separate through filtration like what we did in the lab. You separated sand from the salt and the water together, and we use filtration. So filtration definitely takes advantage of different particle size. So different particle size / sand is bigger in size. So size is definitely a physical property that filtration takes advantage of. You could even talk about solubility and stuff. So solubility and particle sizes are all acceptable answers on the reagents and stuff from this question. Last but not least, number 30, which type of mixture is mixture B? So if you look back at the table, it includes sand, it includes salt, it includes water, and it's all in different amounts, and it's never really the same. So it's definitely a heterogeneous mixture. It's not a solution of stuff, it's just a mixture. Okay, it's not a saltwater solution, it's mixed with sand, it's mixed with salt, it's mixed with water, so it's a heterogeneous mixture because it's all uneven. And there we go, we're done. Yay! I hope that was helpful. Don't forget to study and keep reviewing, guys. And good luck tomorrow. Bye-bye.